Today's math lesson is math lesson 3.9, and we are learning about predicting products. You will need the indigo color and a yellow, and you'll need to set up your journal to have the date in this box and lesson 3.9. Go ahead and push pause on the video until you get this journal set up like this. Inside of this yellow box, you should have written, when you multiply a whole number by a fraction, you are taking a piece of the whole. So when I take 6 times a third, it means that I'm taking 6 times a third means that I'm taking a piece of 6, because 1/3 is just a piece. So I'm taking a piece of 6. So when I solve this, I'm going to put in this little indigo colored box to the right. I'm going to show that the product is going to be blank, comparing, then the whole number, but blank then the fraction. So it's either going to be greater than, less than, or equal to, because this is a comparison bubble. So what we're trying to show is if we take a piece of the whole number, it can't be more than the whole number, because we're just taking a piece of it. So it's going to be, the product will be less than the whole number. But it's going to be greater than the fraction. Let's go ahead and prove this. When I take 6 times a third, remember the easiest way to do this is to put a 1 underneath the whole number and to do multiplication. Now when I do multiplication with fractions, I extend the bar. I look for relationships. The ones just cross each other out, because there's one on top, one on bottom. And then this 6 and 3, well, what can both of those be divided by? They can both be divided by 3. So if I divide this one by 3, I get 1, and this one by 3, I get 2. So I end up with it being 2 over 1. And remember, anything over 1 is just the whole number. So the final answer to that problem is 2. Let's go make sure that our statements over here in the box made sense. The product is less than the whole number. Is 2 less than 6? Yes. Is it greater than the fraction? Is 2 greater than a third? Yes. So we did this correct. Anytime you take a whole number and you times it by a fraction, or vice versa, if you were to take a fraction and multiply by a whole number, using the commutative property, you change the order of those, you would still get 2, no matter what that looks like, and those things would still be true. So the next prediction we're going to make is not with a whole number and a fraction, but it's a fraction of a fraction. So in the next yellow box we're going to make, we'll draw the yellow box at the end, let's write the new scenario. The new scenario is when multiplying a fraction by a fraction. When multiplying a fraction well, what does that mean, a fraction by a fraction? It's taking a fraction times a fraction. So it might look something like this. Well, we're actually going to finish the statement and then we'll write that. So when multiplying a fraction by a fraction, you are taking a piece, because that's what fractions are, it's just a piece. But we're not taking the piece of a whole anymore. We're taking a piece of a piece. We've talked about this before. When multiplying a fraction by a fraction, you are taking a piece of a piece. So let's go ahead right now and make our little prediction box right here. I'm going to outline that with the indigo. The product is Before we said blank then the whole number, but blank then the fraction, where they're just going to be two fractions. So let's go ahead and write this example real quick. Let's say I was doing 2/5 times 3/4. The product is going to be blank, so we're comparing it, both fractions. Think about it. If I take a piece of a piece, if I take a piece of a piece, or a piece of a piece, it's going to be less than both fractions. So it's going to be less than both fractions. So let's just try to solve this out. If I take 2/5 times 3/4, let's rewrite what that looks like right here. 2/5 times 3/4. I would extend the bar, and I'm looking for relationships. So the 2 and the 5, nope. The 3 and the 4, no. What about the 3 and the 5? Nope. And the other ones to check is the 2 and the 4, and they do. The 2 and the 4 can both be divided by 2. So I divide this one by 2 to get 1, and 4 divided by 2 is 2. So now I have a 1 times 3 and a 5 times 2. So 1 times 3 is 3, 5 times 2 is 10. The answer is 3/10. 3/10. Let's circle that up with indigo. And let's go prove our box statement. The product should be less than both fractions. Is 3/10 less than 2/5? Well, let's think about it. If I change this one to tenths, how did I get from 5 to 10? I times by 2, and 2 times 2 would be 4. So this would be 4/10, and this one was 3. So it is less than this fraction. And is 3/10 less than 3/4? Definitely. 3/10, tenths are much smaller size pieces than fourths. So yeah, this statement is true. I love that. I love when we make these predictions and they are accurate and can be proven. The reason why you would want to predict something like this is to find out if you need more or less, or if you're going to have enough. It's just going to come in handy a lot. It also helps you check your answers really quickly to make sure that what you're doing is correct. Another one I want to check is, so we've done a whole number and fraction together, and we've done two fractions. One thing that we haven't done is a mixed number. So let's write this next statement here. When multiplying a mixed number by a fraction, you're going to really have to know what a mixed number is. When multiplying a mixed number by a fraction, you are taking a piece of the whole combined with a piece of the fraction. This one is a little bit longer to write. When multiplying a mixed number by a fraction, you are taking a piece of the whole combined with a piece of the fraction. So we're going to actually use this blue, the indigo, to underline a piece of the whole combined with a piece of the fraction. And then I'm going to circle the word combined with yellow. That's going to be really important, that word combined. Okay, so let me just write what an example would be of this, and then we'll go and make our prediction box. Okay, so let's say the problem was 2.5. Remember, mixed number has wholes and pieces. So 2.5, and I'm timesing it by a fraction. We'll just go, let's do 2/3. 2.5 times 2/3. That's the problem that we're doing right here. Let's go over here and make our prediction box. So if I think about this, is my answer going to be greater than or less than the whole number, the mixed number? Well, I'm going to be taking 2/3 times 2 and combining that with 2/3 of 1.5. So it can't be equal to this, because this would just be one whole if it was going to be equal. And it's not even a whole. So if it's taking less than a whole times this, your answer is going to be less than the mixed number. So we'll say the product is, leave the comparison bubble open, and we'll hurry and answer that. The product is less than the mixed number, but think about it. What about comparing the answer to the fraction? If I take this fraction and double it, times it by 2, and I get a piece of it and then get to combine it, it's going to be more than the fraction. So I should get an answer that is less than 2.5 because I'm only taking a piece of it, but it should be greater than 2/3 because I'm taking 2 times it plus a piece. Does that make sense? Hopefully you're following. Remember, when we do these kinds of problems, we have to change the mixed number into a fraction. So when I change 2.5 into a fraction, it looks like this. Multiply, then add. 2 times 2 is 4, plus 1 is 5, over 2, because the denominator is stubborn and it stays. And this other one's already a fraction, so you leave it as 2/3. So now I have 5/2 times by 2/3. So I'm going to extend the bar. That's what I do with multiplying. And look for relationships. A 5 and a 2, no. A 5 and a 3, no. A 2 and a 2, oh yes, one's on top, one's on bottom. They just cross each other out. So I'm left with 5/3. But you can't leave it as improper. So we're going to fix it. How many times does 3 go into 5? Once. With how many pieces left over? 2. And the denominator is stubborn and stays. So let's just go back to our prediction box and see if this is accurate. Is the product, so this is our product because we multiplied, is the product less than the mixed number? Is 1 2/3 less than this? Yes. But is it greater than the fraction? Is 1 2/3 greater than that? Yes. So we did it correct. That's so awesome. When we get all the way to the end and have done it right. I wish that there was only 3 things that we got to check, but we get to check even more. So the next thing we're going to check, so we did a mixed number by a fraction, right? Okay, now we're going to do a mixed number by a whole. Let's come back over here, turn the page. Ooh, look at the lighting, there we go. So the next one we're doing is multiplying a mixed number by a whole number. And we're going to do the same thing that we had done before, but this time we're going to use, well, actually it'll be just fine. So let's just split our, I'll go about 10 lines down and straight across. This will go all the way off the paper on the right hand side. Okay, so when multiplying a mixed, we'll just say a whole number by a mixed number. Think about what whole number means and what mixed number means. When multiplying a whole number by a mixed number, You are multiplying and combining pieces. That combining thing is going to come in handy again as we have that conversation. Let's go ahead and I can kind of see the outline of my blue prediction box on the other side. So I'm actually going to trace the prediction boxes over here on the left this time. Okay, so let's think about it. When multiplying a whole number by a mixed number, so that would look like something like, I don't know, a whole number by a mixed number. Let's do 1 3/4 times 16. So it would look like this. There's my mixed number, and I'm multiplying it by a whole number. Okay, so the product is, we're going to do that comparison bubble. Blank then, think about it. If I take 1 3/4 and I times it by 16, I'm going to have to do 16 times 1 plus some pieces. So it's definitely going to be more than this. What about, is it going to be more than this one? Well, what's 1 times 16? 16 plus some more pieces of 16. So yeah, it's going to be greater than both. Just like when I did fractions, it was less than both. When I do anything where they're whole numbers, it's going to be greater than both. The product is greater than the whole number and the mixed number. The product's going to be greater than both. I'm just calling it right now. Okay, so let's work it out. Multiply, then add. 4 times 1 is 4, plus 3 is 7 over 4. Times by 16. How do you make 16 a fraction? You put a 1 underneath it. So now when I go to extend the bar, I'm doing 7/4 times 16 over 1. 7 doesn't have a relationship with 4 or 1. 16 does with 4. They can both be divided by 4. If you divide 16 by 4, you get 4. If you divide 4 by 4, you get 1. So I have 7 times 4 and 1 times 1. 7 times 4 is 28. 1 times 1 is 1. So that would equal a total of 28. Go back to your prediction box and make sure that that is true. Is the product greater than the whole number? Is 28 greater than 16? Yes. Is the product greater than the mixed number? Is 28 greater than 1 3/4? Yay! It is. So that works. And then our last one we're going to check. This one is really obvious to me, but we're just going to double check it again. When multiplying a mixed number by a mixed number. Think about that for a minute. We knew that this one got more. So what about this? When multiplying a mixed number by a mixed number. You are multiplying wholes and pieces and combining them. I didn't spell combining right. Sorry, that's going to be blurry for a minute. So you're multiplying wholes and pieces and combining them. So you're not taking just pieces, you're taking wholes and pieces. So here is that prediction box for me. The product is think about this one. Let me give an example of what a mixed number by a mixed number might be. 3 2/3, that's a mixed number, times 1 1/2. So when I get done, if I'm doing it like this, I'm going to be doing 3 times 1 plus 3 times a half and putting that together. Then I have to be doing 2/3 times 1 plus 2/3 times a half and putting it together. So it's going to be greater than both. Greater than both mixed numbers. Let's go ahead and prove that that's true. You ready? Multiply, then add. 3 times 3 is 9, plus 2 is 11 over 3 times by. Multiply, then add. 2 times 1 is 2, plus 1 is 3 over 2. So I extend the bar. It looks like 11/3 times by 3/2. Do you see something I see? Yeah. There's a 3 on top and a 3 on bottom. See ya. So I'm left with 11 over 2. And those don't have a relationship. So you just have to fix it. 11 over 2. 2 goes into 11 5 times. And that would be like taking away 10. Because 5 times 2 is 10. And I have 1 left over. So my final answer is 5.5. Double check that that fit the requirements in your prediction box. Is 5.5 greater than both of these mixed numbers? It's greater than this one, and it's greater than that one. Yahoo! We did it. So finish off this yellow box right here. And then when we come back in the next video, we are going to talk about solving for x and making predictions for that. So we'll catch you in just a minute.